This is Brian Putt. Today I'd like to talk to you about schedule uncertainty for small projects. So why is understanding this cost of schedule important? Let me give you some examples. In recent years, there's been several federal projects that have had large cost overruns. For example, the healthcare.gov website that was launched in 2013 grew from 464 million to 824 million. The Veteran Affairs Hospital currently being constructed in Orlando has more than doubled in cost from 254 to 616 million. And the International Space Station quadrupled in cost from 17 billion to 74 billion. There are other examples that I could give you from Chevron, but let's stop at those. These kinds of overruns in cost and delays in schedule apply not only to these major capital projects, but also apply to smaller projects, maybe operational decisions that have to be made. When should you be conducting these evaluations? Well, it's appropriate at any time and it's applicable to all your projects. We just need to right-size the tool for those projects. We can evaluate the schedule early on and then update it from time to time. And this will provide perspective to the project. And it also gives the ability of the project team to do a self-assessment. So let's look at a model. This is a very simple model. It might be typical of what you'd see in a small project. You go to the subject matter experts and you ask them for an assessment of how long it's going to take. And they give you an assessment, and there are 5 tasks that are going to take 15 days, 7, 18, 13, and 4. And so you link those all together and you find out it's going to take you 57 days. The question is, can they actually accomplish that in 57 days? Well, you go back and ask them some different questions. This time you ask them to give you a minimum and maximum. So let me unhide some cells here. And so now that 15-day assessment, well, we could get it done in 10, but it could take 25. Similar for all the others, we give them a range. Now in this particular model, very simple model, so we're going to change from using this most likely assessment here, and we're now going to treat this as a triangular distribution and look at it with uncertainty. So this first task has an uncertainty range, could be as early as 10 days, but could take up to 25. And similar for all the other tasks. So now let's change this from a deterministic analysis to a probabilistic analysis, or with uncertainty. And what we find is this 57 days has less than a 10% chance of occurring. It's going to be more than 57 days, more than 95% of the time. And where we thought we were going to be completed by the end of the year, there's a very good chance it'll be after the first of the year. Is that important to you to understand that? So with this model in SIPMath, here's the SIPMath toolbar up here, we can easily come in here and change things. So let's say, what if task 3, instead of being 22, was on a high side 30 days? Your subject matter expert, your decision executive says, I think you're being a little optimistic here. And so that 66 days goes to 68 days. I could undo that, 66 days, redo, 68 days. We'll put the 22 back in there. Or what if task 1 was 35 days? That's 69. What if we had both of those? So now I've gone from my 57, which is my reference case, to 72 days to complete the project. So you can see how SIPMath can give you this interactive analysis. You can make it more complicated. Right now, all of these tasks have to be done one right after the other. But what if you said task 4 could be done at the same time as task 3, but it couldn't start until the maximum or till both of these projects, tasks 1 and 2, are completed. So what I could do over here is I could come over here and say, this is equal to the max of this end date and this end date. Okay? And now I get a different answer. They both start at the same time, and now I'm back down to 52 days. Look how we mitigated the issue here. We're actually below what we thought we could do originally by changing the schedule a little bit. Or you might say it's the maximum of these things, but there has to be a 5-day delay in here for whatever reason. And so now I'm back to 57 days. This shows the flexibility of the small little model that easily could be populated by the subject matter experts, and now I have a much better assessment of the uncertainty. If you like more information about SIPMath, you can go to my YouTube channel and search for Brian Putt, and or visit www.probabilitymanagement.org. And it's at this website that you can download the free SIPMath toolbar. Thank you for watching.